Yes? Thank you.
Yep, good to go. Well, thank you. Good afternoon. My name is Yun Ye. Today I'm representing my team in Apple's ads platform to talk to you about our R&D efforts in the area of recommendation systems, specifically the area of controversial item-to-item recommendations. So let's first of all talk about what do we mean by item-to-item recommendation. It is a very common form of recommendation in a lot of online marketplaces, e-commerce websites, as well as media streaming platforms. Basically, it's based on what the user is already engaging in or showing interest in or acquiring. A similar item can be recommended. Let's take some general examples. For example, if a user is streaming baseball games, chances are basketball, football games are going to be of interest to them. Another example, if a user is purchasing, fruit juice, teas or coffee or alcoholic beverages of nature could be interest to them. Last example, if a user is trying to learn music scoring, then educational materials on acoustic equipment or music instrument could be of interest to them. However, in the item-to-item recommendation universe, we often observe that although an item on itself can be perfectly acceptable or safe on its own, given that user has already been engaging in another recommended item or showing interest, all of a sudden, said item in the first place becomes problematic or controversial. So here is an example. If a user is already searching or considering a book titled, vegan recipe or vegetarian food, a book on barbecue cooking probably is not the best recommendations because it's somewhat insensitive considering the user's preference in the first place. In our work, we define controversial item-to-item recommendation as the recommendation that might be conceived as confusing, offensive, insensitive, or downright objectionable, given the user's current context. In the literature, there are quite some works addressing similar or related issues. For example, there are works which deal with fraudulent or offensive contents on their own, which means these items themselves in nature are either fraudulent, problematic, offensive, lewd, which is different from our use case because in our use case, the items we're considering are themselves acceptable in general. So the application scenario is quite different. Methodology-wise, there are literature work in which user behavior or historical user data are heavily mined to establish association rules that's used to identify controversial recommendations. Given we are Apple and we hold the principle of respecting and protecting user privacy and data, this approach is out of our question. So that being said, I want to bring us to the proposed method in our paper. So here is the overall system architecture in the context of an item-to-item recommendation system. We start with the already recommended reference item, which the user is already taking interest in acquiring. To a typical item-to-item recommendation system, we will generate and rank a list of candidates which potentially will be recommended to the users. This controversial detection classifier will take the reference item into one tower, and the candidates will enter in the other tower. So this neural network two-tower model will featureize both items and take the features, concatenate them, and feed it to a fully connected neural net, which works as a classifier. And this neural net will be predicting the level of controversy given this item. And the prediction score is used to filter the candidates before the top ranked items chosen from the clean list is recommended to our users. So as we can see, the central part of this controversial pair detection system is this neural net-based classifier. And next, we'll actually talk about some of the strategies that we have taken in training this neural net in an efficient and effective manner. First of all, choice of training sample is actually very crucial to the performance and business efficacy of an ML system in general. In order to address controversial recommendations in scenarios where it may cause most damage and most adverse impact, we prioritize choice of training samples in terms of the following application scenarios. By the way, we are talking about a prototype and an evaluation scenario in the case of app recommendations, mobile app recommendations. So we choose the 3 application scenarios. First of all, health, wellness, medical, and pharmaceutical applications. Secondly, romance, dating, and relation-related apps. And lastly, any apps that involves monetary activities and financial incentives. And training neural nets usually require quite a bit of data. And in this case of controversial item-to-item recommendation, to identify if a pair of items are controversial and get the training data, we need to engage human labels, which is quite time and labor intensive. But there are techniques in which we can employ that will push the model to converge fast and use the training labels more effectively and efficiently. Essentially, we adopt the active learning approach. The essence of this method is to iteratively label more samples as the models needs it and continuously train the model in an iterative manner. We'll illustrate with some examples. For example, if we want to adopt the active training method to effectively train a classifier that simply tells cats away from dogs, we can train it in the following manner. We can feed unrated samples to the model, and we employ human labelers to only rate samples which the model makes low confidence and unconfident predictions. And we add the newly rated samples into the training set and train the model again, so on and so forth, until the model reaches a satisfactory performance level. By adopting this method in our proposed methodology, we have achieved a low satisfactory model performance with a reasonable number of training samples. So I would like to also reiterate an overall approach in active learning. So in this diagram we are showing, we start by obtaining human rating for a small portion of unlabeled training samples, and use these samples to train the model. Now what we get is a functioning, but maybe not optimized or satisfactory model. We then let the model score more unlabeled samples, choose those samples with lower confidence, which is closer to the decision boundary. We let these human raters to rate these low confidence samples and add them as our new training samples. And so on and so forth with this approach. Every iteration, we are very purposefully selecting new training samples to improve the current model, where it performs like previously in a very unconfident manner. Eventually, we'll end up with satisfactory model performance with a low cost and effective manner. With that, finally, we can take a look at the performance of the proposed solution. We need to compare it with a baseline. Given the premises of we don't have much or actually at all any user data or user behavior data. What we have is only the app side data. And we build our baseline using the embedding cosine distance as a measure of controversial level. And we compare that classifier with our proposed item-to-item controversial pair detection algorithm. We can see that proposed method delivers a much higher AOC performance. And at very similar recall, our proposed method actually have a much better precision level. I think during the conversion of the slides, there was some issue showing the title of the page. So the first column is showing area under the curve. Second column is a recall. The third column is precision. In conclusion, our work addressed the problem of controversial item-to-item recommendations. In order to improve user experience in a general recommendation system scenario, we applied active learning as a technique to train neural nets in a cost-effective manner. And very importantly, our proposed approach does not make use of any tracking or historical user behavior data at all. So with that, it comes to the end of the presentation, and I'll take some questions, and I'll try to answer them with the best of my ability. Thank you.
Thank you. Questions are popping in, and also the microphone is taken. Sure. Joe?
So I want to understand the constraint of your problem better, because I think a lot of this comes from the fact that you have no personal user data. In most of the world, if we had a recommender system that was producing offensive pairings, we'd say the recommender is bad and needs to be improved. We wouldn't go back and say, well, we need a separate model to filter them out after the fact. So what's the assumption you're making about the base recommender that's producing things that now have the opportunity to become bad combinations?
Understood. So I think there are two concerns here. First of all, in a more legacy system and legacy capability point of view, recommendation systems are often trained to optimize KPIs like conversions and clicks. Of course, there are emergent sorts or school of methodologies in which like multi-objective learning can be adopted to train an overall all-in-one recommendation system, which has both conversion optimization considerations as well as content suitability and controversial pair detection capabilities. So that's certainly a possibility. But in this work, we did not make that choice or did not take that approach. Instead, we started with really like an expert system, I would call it, that focus on one task alone, which is detecting controversial pairs first. But that, I don't think, hinders us or stops us to build that into an overall recommendation system. Instead, I'll see it as a first step.
So it sounds like one application of your work that would be really interesting is if you had circumstances where the recommendations were not offensive in general, even to somebody. So it's not that a person who likes cats would never be interested in dogs. It's that when I'm looking at a cat right now, it sounds like you don't get it when I look at a dog. Or to use the medical example, if I'm looking at an app to manage a serious disease, that's not the day I want to get the recommendation for an app to pre-plan my funeral. It's a little too close. Yep. Maybe 3 days later I should get that recommendation because it would be good for me, but not at the same time. And it sounds like this might be the kind of application you could use there.
Yeah, the user context at the moment is really important. Yeah.
Okay, thank you. There's so many questions on Slido, it's really hard to pick. So I pick yellow. Have you considered a model that does not rely on human labeling For instance, looking at whether the user have not bought any meat at all in the past, if you want to go for vegan or so.
Right, that's certainly an approach we can rely on. So human rating is what we consider the golden standard in terms of getting the most reliable labels. So, like of course in the literature, recent literatures, there are also works in which like a ChatGPT kind of a machine learning system is used to label data. But once we go up to scale, issues like hallucinations, unreliability will surface. That's with that approach of new methodologies. Looking at user engagement behavior, excluding the privacy and user behavior, user data issues, even if we look at it as a collective, I think engagement signals are impacted by too many different factors. So we can't really want to build a starting model that has a very clean and very reliable set of labels. That's why we start with human labels. Yeah.
Okay, thank you. I have a question myself. So it relates somehow to what Joe said, somehow. Isn't it that it's very user-specific or situation-specific if something could be perceived as offensive or not? For instance, if, like, take the vegan meat thing again, if someone is really purely vegan and has a strong opinion about that, then the combination with meat cooking book is not a good choice. But for instance, I like to, if I want to have food and cooking books, then I don't like vegan meat, everything is fine. So even the labeling is very user-specific or can be situation-specific, as it was mentioned before. How can we deal with that, or is there any thoughts to move forward?
Right. So I think, first of all, in our human labeling process, we don't have like a single labeler, single sample kind of scenario. We do have like multiple samples for multiple ratings for the same sample. So we have some collective aggregation methodology to kind of reflect how different people will respond to the same recommendation. So that's in the rating and in the label generation process. Second of all, at the end of the day, it's a classifier. So the level of strictness, the level of harshness of how harsh this filter is controllable by setting a threshold. So there is always a trade-off to be carefully managed by adjusting that threshold and continuously improve the model, I would say. And finally, I think this model can be always intended as like a guardrail to really guide things that's going to be objectionable to a lot of people. And yeah, that's our current thinking about that. Yeah.
Okay, thanks a lot. Let's thank you for this talk.
Thank you. Thank you.